Object-oriented programming in C++. There are some online tutorials that are helpful. I would suggest going through these. These are not very long. Object-oriented programming allows us to assemble a program from various pieces if we wish. Traditional procedural-oriented programs are not quite as flexible as we might like. As you get to bigger and bigger programs, object-oriented programming allows us to have more complexity and still have the ability to easily manipulate variables and such. So object-oriented programming has a class. Each class has a name, attributes, which are its information that's stored with it, and behaviors. Each of these can send messages between each other. These would each be separate classes. A class should do one thing and do one thing really well. In this instance, for a game that keeps track of a computer soccer game, we have one that keeps track of the player, the ball, the field, the referee. All of these do specific things, and they communicate with each other. They can be reused in other applications. OOP allows us to have ease in software design, maintenance, it's reusable. We have classes, we have instances. What is a class? As we mentioned earlier, class has a name. It has data attributes, which means information stored in the class. It has operations. And here's an example. The student stores the name and the grade. The student can get name or print the grade. A circle has a radius and a color. It can get the radius or get the area. A class is a programmer-defined, abstract, self-contained, reusable software entity that mimics a real-world thing. Let's take a look at some examples. We have a class, we have some data, we have some functions. Here is a room class. We can store the length, width, and height. We can calculate the area, we can calculate the volume. Same with soccer player and circle. We have some conventions that we're going to deal with in C++. It's usually lowercase and then everything after that is uppercase. That's called camel case. A member function has a couple different things it can do. It receives parameters, it performs operations, it returns information. Usually our function name, it starts with a lowercase and then uses camel case from that point on. We also have access control, and C++ enforces that. Public is accessible to all parts of the program. Private is accessible and available within this class. We have two different ways to let us know which is which. When we use a set method, function in C++, we're bringing in radius from the outside world. Well, we also have radius in here. How do we know the difference? In this case, we can do this radius, which is a pointer to radius. That's one method to do it. Or you can use an m underscore to mean member radius. So then we have m underscore radius equals radius. Let's look at a spaceship tutorial. Typically, we're going to define the class in the upper part of the program. So we're going to have three private data members: length, width, and height. The M meaning that it's a data member. We're going to calculate the area. We're going to calculate the volume. We're going to insert data into this. How does that work? Well, in C++, you do spaceship. That's the class. This is the object. We use what's called the dot operator to access the member functions of our object. Class object is an instantiation of the spaceship class. We're going to insert this data using this guy, this method or function. Length goes into here, which is assigned to the internal length. That's part of the class. This guy comes in here, is assigned to the member width. This guy comes in here and is assigned to the member height. So we can bring information from the inside world Here we're returning information to the outside world. And we're using the return calculate area right here. When we calculate the area, we're using the internal information and returning that value. And we're returning the value. And there we have some information about our square spaceship. I'll take a look and run this guy real quickly. I think it's just called spaceship. Yep, there we go. So our spaceship area and our volume of our spaceship. Now we're going to look at a couple more pieces. When we create an object, we're automatically using what's called a default constructor. This creates an empty object with nothing in it. Well, we can also create an object that has values placed into it at the same time we create the object. We pass these in as parameters. These parameters get passed into the data members. How does C++ know the difference? It looks at the signature. The signature of a function or method is what is being passed into it. Nothing, three things. If we go down and look at that in the code, this is using the default constructor. This is using the parameterized constructor because we're passing in three pieces of information. We can also overload other methods. Let's see, where's the other one? Oh yeah. Calculate area. We can either calculate based on what's coming in internally. We can calculate based on what we're passing in. C++ determines by the signature. Is there a parameters or not? This case, we have to have two of them. We have to have a default constructor and insert the data. With this one, we can do it all at once. It just depends on what you want to do. And we calculate the area, calculate volume. Oop, look at here. We just calculated the area and we inserted two pieces of information to calculate the area. Now we're going to look at the final pieces. We still have our private data members. We have our two different constructors, our default and our special constructor. Now typically you're going to have what are called getters and setters. And notice they both have the same name. How does C++ know the difference? This one is returning a value, and this says set the length, and that's backwards. This is getting the length, and this one set the length. So I said getters and setters. Well, that's typically the order you do it, say it, and do it in, so I should reverse these. You call them getters and setters. There. So now we are, and I had it the right way around to begin with. There we go. Getters and setters. Set the length, get the length. So we can change them individually. Well, in the code, how do we know which one is going where? Like this. If we're assigning a new value to the property, it's a method that's on the assignment end. The information is going from the outside into the spaceship. How do we know if it's a getter? It's going from the spaceship out. With this cout statement, we were retrieving the value that's in the length property. So we retrieve the value, we change it, we retrieve it again. Let's run this guy and see how that works. There. See, the original value is 98.3. We inserted a new value, and now it's 204.5. You might use this for as the fuel gets expended, you may want to subtract some fuel. Classes in C++ follow all the normal things that other programs follow. We have private data members, we have constructors, we have properties or getters and setters. We have methods that calculate and return. We have methods that just do things. We can create any number of objects from those classes. As the program gets longer, and you can see this is getting a lot longer, we probably need to divide our class into a separate file. Well, that will be coming up in a future episode of Square Spaceships.